Hi, I'm Teacher Hernan and welcome to Math for You. In this video, the topic is about greatest common factor. But before we start, please do subscribe if you are new to this channel and click that bell icon if you want to be updated with all my latest videos. Now let me show you a picture of what is greatest common factor is all about. Look at here, given the dividends and the missing divisors. Can you tell me what is the biggest divisor that when you divide by 18 and 24 will give you a remainder of 0? Yes, you're right. The biggest divisor that can you put here when divided by will give you remainder of 0 is 6. You're correct. So if you divide this by 6, that's 3 remainder 0. If you divide this by 6, that's 4 remainder 0. So when we talk of greatest common factor, it simply means we are getting the biggest divisor of 2 or more numbers. There are many ways how to get the greatest common factor of 2 or more numbers. But in this video, I'll be discussing with you the two most common ways how to get the GCF. Now let's have the first way how to get the GCF, or greatest common factor. That is the listing method. From the word list, you simply list down all the factors of each number. Like here, the factors of 12, we have 1 times 12, 2 times 6, 3 times 4. Those are the factors of 12. If I were you, you have to list the factors, list to greatest. What about for 15? The factors of 15 are 1 times 15, 3 times 5. So these are the factors of 15. So after you list down all the factors of each number, next thing for you to do is to get the common factors. What common factors can you see? Both have 1. That's common. Both have 3. Can you see other common factors here? None, right? So the only common factors of 12 and 15 are 1 and 3. And which is the great? Here there are only 2. So the greater common factor is 3. And that 3 is our greatest common factor, or GCF. Meaning, 3 is the biggest divisor that can divide 12 and 15, leaving no remainder. Now let's use 3 numbers and get their greatest common factor. Let's start with 20. The factors of 20 are 1 times 20, 2 times 10, 4 times 5. For 32, we have 1 times 32, 2 times 16 is 32, 4 times 8 is 32. For 42, we have 1 times 42, 2 times 21, that's 42, 3 times 14 is 42, and 6 times 7 is 42. So these are the factors of 42, factors of 32, and factors of 20. The next thing for you to do is to get their common factors. So both, or all the 3 numbers have factor 1, 2, what else can you see? No more, right? So the only common factors of these 3 numbers are 1 and 2. The bigger is 2. So that is our greatest common factor. Let's have the second way how to get the greatest common factor, and that is the continuous division process. So here, you simply divide the numbers. Be sure there are no remainders. Okay? I hope you watched my video on divisibility rules, because we can use divisibility rules here for easy solution. Okay, let's start with 45 and 72. Let's start divisible by 2. Both numbers, I mean 45, not divisible by 2 because it's not even, right? What about 3? If you add the digits, 4 plus 5, that's 9. 7 plus 2 is 9. Both are divisible by 3, meaning you can divide them by 3. Let's divide them by 3. If you divide them by 3, you get 15. 45 divided by 3 is 15. 72 divided by 3 is what? 24. Correct. Then continue. What do you divide 15 and 24? By the way, you can start any divisor here, as long as you can divide the numbers, leaving no remainder. Okay, but if you cannot think of bigger number, you may start 2, 3, 4, 5, so on. Again, the divisibility rules can help you a lot. Let's continue. Still, the numbers are divisible by 3, because if you add the digits, that's 6. 2 plus 4, that's 6. So still divisible by 3. Let's divide them by 3 again. 15 divided by 3 is 5. 24 divided by 3 is 8. But look at 5 and 8. The only number you can divide them is 1, or the common factor is 1, right? So meaning you stop here. So how to get the GCF now, the greatest common factor? Okay, just get these two divisors here, or the divisors here, multiply them. So we multiply 3 times 3. So the GCF of 45 and 72 is 9. Again, it means the biggest divisor that can divide these two numbers is 9. That's the GCF. Now let's use 3 numbers, 21, 30, and 45. What is their GCF? Again, let's use the divisibility rules. Let's start with 2. 21 is not even, so it's not divisible by 2. Again, here, if there are 3 or more numbers, be sure you can divide all the numbers. So for this number, not divisible by 2, right? So let's go to 3. Are the numbers divisible by 3? Yes. I can divide by 3. So with this, and so with this. So let's divide them by 3. 21 divided by 3 is 7. Divided by 3 is 10. Divided by 3 is 15. Correct? Next, what about 7, 10, and 15? What can you divide them, leaving remainder 0? Aside from 1. Only 1, right? Their only common factor is 1. So meaning, if you cannot divide all the numbers, you have to stop there. Since we have only one divisor, we only use one divisor, so that is our GCF 3. Now let's deepen your understanding on greatest common factor by solving word problems. Let's have number 1. What is the biggest number that can divide both 70 and 91, leaving a remainder of 0? If you are looking for the biggest number, your clue here is the word biggest number. So if you are looking for the biggest number that can divide 2 or more numbers, leaving remainder 0, you are simply getting the greatest common factor. So just get the greatest common factor of 70 and 91 to answer this problem. So you may use any of the two ways, whether the listing method or the continuous division process. But since I don't need the common factors, so let me use the continuous division process. So let's divide. Let's think of number. Again, you can start any number. Be sure when you divide, there is no remainder. So what number can you think that can divide both numbers, leaving no remainder? 2, not possible. 3, 4, what do you think? Yes, 7, right? If I'll divide this by 7, that's 10. If I'll divide this by 7, that's 13, correct? What about 10 and 13? What can you divide them aside from 1? Only 1, right? Their only common factor is 1. So meaning we stop there. So it's understood that our GCF is 7. So meaning the biggest number that can divide these numbers here, leaving a remainder of 0, is 7. So our answer here is 7. Let's have one more word problem. The problem is James wants to cut three strings measuring 24 meters, 30 meters, and 42 meters equally. What is the longest possible piece that he can cut? So to solve this problem, you simply get the greatest common factor of 42, 30, and 42. So let's again, since we don't need the common factors of the numbers, so let's use the continuous division process. But I'm not saying you cannot use the listing method. You can still use the listing method. You can use any of the two. You will arrive at the same answer. But here, since I don't need the common factor, so let me use the continuous division process. So let's get the greatest common factor of 24, 30, and 42. Again, think of a number that you can divide all these three numbers. Again, let's use the divisibility rules. Let's start with 2. All numbers are even, right? So I can start with 2. So if I'll divide this by 2, that's 12, 15. This will give you 21. Can you still divide them by 2? These two are no longer even. Let's have 3. I can divide this by 3. The digits, the sum is 3. Here, the sum is 6. 3. So they are divisible by 3. So we can divide them by 3. Divide this by 3, you get 4. This one, 5. Divide by 3, you get 7. What about for 4, 5, and 7? If you notice, their only common factor is 1, meaning you can only divide them by 1, leaving 0 remainder. So meaning we will stop here. So how to get the GCF? So we multiply 2 times 3, which is 6. It means that the longest piece, meaning one piece of a string, the longest that he can cut is 6 meters. So the answer there is 6 meters. I hope you learned something in this video. Thank you for watching. See you in the next video.